Hello, and welcome to RepairSolutionsPRO how-to video series. My name is Steve Caruso, and in this video we're going to walk you through the full diagnostic and repair process for DTC P0171 System 2 Lean Bank 1 on a 2007 Toyota Matrix. Before jumping into diagnostics, always start with a full inspection of the vehicle. Document the symptoms and background information. This can include: when did the issue first start? What did the driver notice? Were there any previous repairs? What was the driving conditions when the problem occurred? What type of fuel was being used? And are there any warning signs that occurred, such as smells or strange noises? This information will help prepare you for your diagnostic strategy and possibly reduce your diagnostic time. Once you've collected this information, begin your initial inspection by checking for obvious mechanical problems. Look for torn intake boots, cracked vacuum lines or tees, or damaged or disconnected wiring harnesses. Make sure all the harness connectors are fully seated and in the locked position. Check the connectors for corrosion, broken pins, or frayed wires. After the visual inspection is done, connect your 7111 scan tool to the DLC. Turn the key to the on position, engine off. Use the tool to retrieve DTCs and freeze frame data. In this case, we're dealing with DTC P0171 System 2 Lean Bank 1. This means the computer has reached its maximum fuel trim limits. Look at the freeze frame data to understand the engine conditions when the code was stored, such as RPM, engine load, coolant temperature, and fuel trim values. These details will help recreate the conditions that triggered the fault. Next, review the vehicle's service and maintenance history. This includes any work that's been done recently, like engine repairs, spark plugs, O2 sensors, or anything that might affect fuel or emission systems. You'll also want to search for any TSBs related to this code or the vehicle's year and model. When diagnosing a P0171, it's important to consider what's causing the fuel trim to reach its maximum limits. Look for any of the following: faulty mass airflow sensors, degrading air-fuel ratio sensors, degrading heated oxygen sensors, failing fuel injectors. Each of these issues can lead to a lean air-fuel mixture, causing the engine control module to add fuel to its maximum fuel limits. By combining the scan tool results, freeze frame data, and repair history, and possible root causes, you'll have a better understanding before moving forward with your diagnostic routine. Next, we'll run a few tests to figure out exactly what's causing this code. Start the engine and let it idle. Using your scan tool's live data mode, look at the engine coolant temperature. It should be between 85 and 105 degrees Celsius. If it's not, the engine may not be running at operating temperature. Now let's look at some more vehicle information using your live data mode. We're going to be focusing on the long-term fuel trim Bank 1, mass airflow sensor, and the oxygen sensor readings to help determine how well the air-fuel mixture is being controlled. When inspecting the mass airflow sensor, start by looking at fuel trim values at idle. These numbers are greatly influenced by vacuum leaks.
Check the long-term fuel trim at idle and 2500 RPM. The value should be no more than plus or minus 10%. If long-term fuel trim is greater than 10% at idle, but less at 2500 RPM, suspect a vacuum leak. If the long-term fuel trim is greater than 10% at idle and at 2500 RPM, suspect a mass airflow sensor. Since the long-term fuel trim is greater than 10% in both conditions, let's move to the next step.
Check the mass airflow sensor readings at both idle and 2500 RPM. At idle, mass airflow values should be around 1.4 to 2.3 grams per second. At 2500 RPM, mass airflow values should be about 5.4 to 7.9 grams per second. If the values are out of specification, replace the mass airflow sensor and perform repair validation. If the values are within specification, suspect fuel pressure, fuel injector, etc. In this case, the values were out of specification, so replace the mass airflow sensor and perform the repair validation. Now that we confirmed the mass airflow sensor is faulty, we're going to replace it. Follow the procedures step by step for removal and installation. Safety first. Always wear your safety goggles and your safety gloves. Turn the ignition off and remove the key. Wait at least 30 seconds to allow the PCM to power down. The mass airflow sensor is located in the air filter assembly. Press the tab and carefully pull the MAF connector straight out. Do not pull on the wires. Use a Phillips head screwdriver to remove the two screws securing the mass airflow sensor into the air intake duct. Gently remove the mass airflow sensor by pulling it straight out. Be careful not to damage the sealing surface or the sensor element. Inspect and clean the mounting areas. Ensure that no dirt or debris is present in the sensor housing or the air duct. When you're installing the new mass airflow sensor, slide it into place and make sure it is fully seated. Secure the mass airflow sensor by inserting the screws and snugging it down. Do not over-tighten the screws. Torque to 26.5 to 44.2 inch-pounds. Reconnect the electrical connector. Push it in until you hear a click. Once the mass airflow sensor is installed, it's time to confirm that everything is working correctly and the repair fixed the issue. Follow these steps, clear the diagnostic trouble codes, freeze frame, and the I&M readiness data stored in the vehicle's computer using your scan tool. Review the trip cycle for the appropriate monitor with the vehicle in the key on engine running position, ensuring that the monitor icon is showing red, which means incomplete. You can follow the trip cycle in the tool or the OBD2 drive cycle as outlined in your service manual or emissions guide. This ensures the systems recheck the mass airflow sensor's performance. After completing the trip or the drive cycle, use the scan tool to check for I&M readiness data status, pending or confirmed DTCs. If there are no codes present and the I&M readiness status is green, the repair is complete. This concludes the entire process for fixing P0171 on a 2007 Toyota Matrix. Thanks for watching, and for more information visit us at pro.repairsolutions.com.